Okay, so in the first three sections of Chapter 8, we have looked at how to solve a system of equations. So we've done two variable systems where we did graphing, elimination, and substitution, and then we looked at three variable systems where it was kind of a mix between substitution and elimination. So something else that comes into play with linear systems is matrices. A matrix is just a rectangular array of numbers. Matrices is the plural of matrix. So if you're talking about one, it's matrix. If you're talking about more than one, it's matrices. So something that you have to be able to do when you're talking about matrices is determine the order of a matrix. The order is always the number of rows by the number of columns, or R by C, rows by columns. So when we look at this matrix over here, we have 2 rows and 3 columns. So we got row 1, row 2, column 1, column 2, column 3. So it's a 2 by 3 matrix. So in 1 and 2, we're just determining the order of the matrix. How many rows by how many columns? So in number 1, we have the matrix 3, negative 2, negative 4, 0, 2, negative 7, negative 1, negative 3. So when we are determining that order, we have 1, 2, 3, 4 rows and 1, 2 columns. So it's a 4 by 2 matrix. Same thing in number 2. We've got a matrix of 13, 12, negative 9, and 0. So we have 1 row and 4 columns. So it is a 1 by 4 matrix. So something that we can do with matrices is we can take a system of equations and we can turn it into a matrix. There are 2 main types of matrices that we can use. We can do what's called a coefficient matrix, which is simply just the coefficients of your equations. So it's just the numbers that are in front of your variables. So if we look at this system that we have on the left, x minus 4y plus 3z equals 5, negative x plus 3y minus z equals negative 3, and 2x minus 4z equals 6. So we're just taking all those numbers in front of those variables and turning it into a matrix. So our first row is just that first equation. We have a 1x, a negative 4y, a 3z. So we've got 1, negative 4, 3. And then the second we have negative x, 3y, negative z. So negative 1, 3, negative 1. In that last one, we have 2x. We don't have any y's, so 0y, and we have negative 4z, so 2, 0, 4. Now, we also have what's called an augmented matrix, which is just the same thing as your coefficient matrix, but then we're adding a column for what all of those equations are equal to. So before this line here represents the augmented matrix. It basically is our equal sign. Before that, we have just our coefficient matrix. After that, we have what every equation was equal to. So the first equation was equal to 5, the second one negative 3, the third one 6. So what we want to do in number 3 is we want to write the system as a coefficient matrix and then as an augmented matrix. So if you feel confident, pause the video, do it yourself, come back and check your answer. So for our coefficient matrix, it's just the numbers in front of the variables. So in our first equation, we have 4x and negative 5y. So 4, negative 5. In our second equation, we have negative 1x and 8y. So negative 1 and 8. That's our coefficient matrix. Our augmented matrix, we're still going to have that 4, negative 5, that negative 1, 8. But we got to add that line that's essentially representing our equal sign and write what those two equations were equal to. The first one was equal to negative 2. The second one was equal to 10. We also can take an augmented matrix and turn it into our system of equations. We do that by just taking those numbers and putting them in front of our variables. So if it's 3 variables here, got 3 columns before our line to represent the equal sign. So it's just going to be basically x, y, and z. So we've got 1x plus 0y plus 2z equals whatever's on the other side of that line, so negative 10. And then 0x plus 3y minus z equals 5, and 4x plus 2y plus 0z equals 3. Now, do you have to put the zeros in there? No, you do not. So if you prefer, you could write those as x plus 2z equals negative 10, 3y minus z equals 5, and 4x plus 2y equals 3. You do not have to write the 0y, 0x, or 0z. That's just depending on if you need that to know what you're looking at or not. If you need it, add it in. If you don't, leave it out. Elementary row operations, this is basically what gives us the opportunity to solve a system of equation using matrices. So an elementary row operation is just any of these 3 operations performed on an augmented matrix. So we can interchange 2 rows, meaning we can completely swap those values, take the second row and make it the first row, and then the first row becomes the second row. We can multiply a row by any non-zero number. So it can be a decimal, fraction, whole number, it doesn't matter as long as it's not 0. And we can add a multiple of a row to another row. So we that's basically like our elimination. So when we solved by elimination, we would say, okay, I need to multiply this equation by 2 and this equation by negative 3. We would do that, and then we would add them together. So this third one here is really just a different way of looking at an elimination type process. So you can do any of those 3 things, and it's going to produce a matrix that's row equivalent to the original. So 2 matrices are row equivalent if one can be obtained from the other by a sequence of elementary row operations. So basically, as long as you're doing one of those 3 things, no matter how many of those row operations you do, it's going to be equivalent to the original. Okay, so in 5 and 6, we're just performing the row operation. So in number 5, we have a matrix of 1, 1, negative 4, 2, 0, 0, 8, 3, 0, 4, 5, 5. And when you have arrows like we do here, that's just telling you it wants you to swap those 2 rows. So when we rewrite that matrix, the second row is going to go first. So we have 0, 0, 8, 3. The first row is going to go second. So 1, 1, negative 4, 2. And then the third row stays the same. And then in number 6, 1/9 times R1 or row 1. So we're just multiplying every single number in that first row by 1/9, which is the same thing as dividing by 9. You can use your calculator if you don't feel confident doing it in your head, that's fine. But you have to multiply every single number in that row. So 9 times 1/9 is 1. Negative 18 times 1/9 is negative 2. 27 times 1/9 is 3. And we leave that second row alone. Okay, so I'm going to show you how to solve a system of equation using matrices. We do that by using elementary row operations, And basically what we're going to do is we're going to write an augmented matrix. So I'm going to do that first for you. So 1, -2, -1, 6, 0, 1, 4, 5, 4, 2, 3, and 8. Okay, so I'm going to take that augmented matrix and I'm going to perform row operations until I get a main diagonal. So from going from this top left corner up here at 1 down to this bottom right corner where I have 3, I want all 3 of those numbers to be 1. Anything to the left of those numbers I want to be 0. That's going to give me the easiest possible way to solve. So I started out a little bit easier for us because we already have a 1 in this first row, the first row, first entry. So if we look at row 2, we didn't have an X in that system, so that's automatically a 0, and then our Y value had a coefficient of 1. So I already have a 0 in that first spot and a 1 in that second spot, which is what we want. So really we have to focus on turning this 4 in the third row to a 0, the 2 to a 0, and the 3 to a 1. So the first thing we're going to do is we're going to get the 4 to become 0. So if we think about that in terms of elimination, we would say, okay, well, my first row or my first equation has a 1. So if I multiply that by -4 and add them together, that's going to give me 0. So -4 times row 1 plus row 3. So I'm going to leave my first 2 rows exactly the same because the only row I want to change is my third row. So -4 times 1 is -4 plus 4 is 0. And then I go to the next number. -4 times -2 is 8 plus 2 is 10. -4 times -1 is 4 plus 3 is 7. And -4 times 6 is -24 plus 8 is -16. Okay, so I want you to take a second, make sure you have that jotted down. If you aren't quite sure what I did there, go back and rewatch that step. Okay, so I multiplied every number in the first row by -4 and added it to the third row. Okay, so now I want to focus on getting this 10 in the third row to also be 0. So we don't really want to use the first row because we have a 1 in that first entry, and that's going to affect the 0 in the first entry of our third row. We don't want to do that. But if we use the second row, we have a 0 in the first entry and a 1 in the second. So we can multiply that 1 by -10 so that when we add it to the 10 in the third row, it becomes 0. So -10 times row 2 plus row 3. So again, my first and second row are going to stay the same because I only want to change the third row. So -10 times 0 is 0 plus 0 is still 0. I didn't want that to change, so that's good. -10 times 1 is -10 plus 10 gives me 0. -10 times 4 is -40 plus 7 is -33. And -10 times 5 is -50 plus -16 is -66. So I've got a 1 on the first row, first entry, a 1 in the second row, second entry, and then a negative 33 in the third row, third entry, but I'd still have those zeros all to the left of it, which is what I want. So remember, I want zeros to the left, ones down that diagonal. So now I just have to focus on getting this negative 33 to become a positive 1. So negative 33 divided by itself is going to give me 1. So dividing by negative 33 is the same thing as multiplying by 1 over 33, or negative 1 over 33. So I'm going to multiply that whole row by negative 1 over 33. My first two rows stay the same. And then I'm going to multiply everything in my third row by negative 1 over 33. So when I multiply that by the zeros, it's still 0. Negative 1 over 33 times negative 33 gives me positive 1. And negative 1 over 33 times negative 66 gives me positive 2. So now that I have ones down my diagonal and zeros to the left of that, I'm ready to solve for each variable. So remember, it's the variables in order as they're written in our system. So x, y, and z. So I've got 0x plus 0y plus z equals 2. So I already know z equals 2. Now I know that 0x plus 1y plus 4z equals 5. Well, I know that z is 2, so if I plug that in for z, I can use that to solve for y. So y plus 4 times 2 equals 5. 4 plus 2 is 8. I subtract my 8 to get negative 3 for y. And I can take that z value and that y value and plug it into my first row, which is x minus 2y minus z equals 6 to solve for x. So x minus 2 times negative 3 minus 2. Negative 2 times negative 3 is 6 minus 2 equals 6. 6 minus 2 is going to give me x plus 4. And when I subtract my 4, I get 2 for x. And just like we did in the first 3 sections, we always write our final answer in either an ordered pair or an ordered triple. In this case, an ordered triple. So 2, negative 3, 2. Okay, so in number 7, I did one that was a little bit harder in hopes that these next couple would be a little bit easier for you to get through. We went from 3 variables to 2 variables. So we've got 6x minus 4y equals 2 and 5x plus 2y equals 7. So we're going to write that as an augmented matrix. And we want, remember, our diagonals to be 1 and anything to the left to be 0. So we want our 6 to be 1, our 2 to be 1, and that 5 to become a 0. So what I would do first is I would turn the 5 into a 0. Because I think we're going to end up with some fractions here, and I think it'll make our life a little bit easier if we do that first. So if we were solving just the system with elimination, we would say, okay, I'm going to multiply my first equation by negative 5 and my second equation by 6. So with a matrix, we're going to say, okay, I'm going to multiply row 1 by negative 5, and I'm going to add it to 6 times row 2. So if you need to write this off to the side, that's fine. Negative 5 times 6 is going to give us negative 30. Negative 5 times negative 4 is going to give us 20. And 2 times negative 5 is going to give us negative 10. And then 6 times 5 is going to give us positive 30. 6 times 2 is going to give us 12. 6 times 7 is going to give us 42. So if I add these two together, that's going to give me my new second row. Because remember, we're just changing the second row. So negative 30 plus 30 is 0. 20 plus 12 is 32. And negative 10 plus 42 is 32. So I know I want my first row to have a 1 first. So if I want to get this 6 to become a 1, I need to multiply it by 1/6, or essentially divide it by 6. So 1/6 times row 1. So 1/6 times 6 is 1. 1/6 times negative 4 is negative 4/6, which is going to simplify to negative 2/3. And 1/6 times 2 is 2/6, which simplifies to 1/3. And my second row stays the same. Now I want this 32 to become a 1. So if I multiply that by 1 over 32, that whole row, it's going to give me that 1 that I need. So my first row is going to stay the same. 0 times 1 over 32 is 0. 32 times 1 over 32 is 1. And then another 32 times 1 over 32 is 1. So I've got my 1s on my diagonal, 0 to the left of that, so I'm ready to solve. So 1y equals 1 solves my y value. And then I'm going to plug that in to the first row so that I can solve for x. So I've got 1x minus 2/3 y equals 1/3. So I'm going to plug in my 1 for y. So 2/3 times 1 is going to give me x minus 2/3 equals 1/3. I'm going to add my 2/3 to the other side. 1/3 plus 2/3 is 3/3, which is just 1. And as always, we got to write our final answer as either an ordered pair or an ordered triple. In this case, an ordered pair of 1, 1. All right, so in number 9, we're doing the same thing. If you feel confident in your ability or you want to just try to see how far you can get, go ahead and pause and get through what you can get through and then come back and watch how I've done it. One thing you want to keep in mind is there are always going to be multiple different ways that you can solve these. So you might do steps in different orders, things like that, or you might do a different first step, which is going to affect your steps after that. As long as you get the right answer in the end, the way you get there does not matter. So if one of you decides, oh, I think it'll be easier if I change these rows, and the other one's like, I'm just going to multiply first, that's fine. As long as you're getting that final answer, that's all that matters. So I'm going to write my augmented matrix first. Now, when I look at this, I notice that in my first row, my x value is 12. In my second row, it's 4. I don't like it when I have a bigger number in the first row than in the second row. So I'm going to choose to just swap those right off the bat. So my second row is just going to become my third row, and my first row, or sorry, my second row is just going to become my first row, and my first row is going to become my second row. Because now I can say, okay, well, if I multiply 4 by 3, I get 12. So if I want those to add to 0, I'm just going to multiply my first row by -3 and add it to the second row. So 4 times -3 is -12, plus 12 is 0. And remember, our first row is going to stay the same. -3 times -3 is 9, plus 10 is 19. And -3 times -11 is 33, and 33 plus -14 is 19. And I know that I need my 19 in that second row to become a 1. So I'm going to go ahead and I'm going to multiply my second row all by 1 over 19. So my first row is going to stay the same. 0 times 1 over 19 is 0. 19 times 1 over 19 is 1. And 19 times 1 over 19 is 1 again. And then I know that I need this 4 in my first row to become a 1. So I'm going to multiply my first row by 1/4. So my second row is going to stay the same. 1/4 times 4 is 1. 1/4 times -3 is -3/4. And 1/4 times -11 is -11/4. So I've got 1s on my diagonal, 0 to the left of those, so I'm ready to solve. So I've got 1y equals 1. So my y value is 1. And then in my first row, 1 -3/4 -11/4 is going to be 1 minus 3 over 4y equals -11/4. So I can plug in that 1 for y to solve for x. So x minus 3/4 equals 11/4. I'm going to add my 3/4 over -11/4 plus 3/4 is going to be -8/4. -8 over 4 just simplifies down to -2. And as always, final answer as our ordered pair. So -2, 1. Okay, so number 10, we're going back to 3 variables. So write your augmented matrix. So 2, 4, 0, 10, 2, 2, 3, 3, -3, 1, 2, -3. So, excuse me, in my first row, all my numbers are even, and I know I need that 2 to become a 1. So I'm going to go ahead and I am going to multiply everything in that first row by 1/2. So it's going to become 1, 2, 0, 5. And then all my other rows stay the same. So this just makes it a little bit easier for me to get that 2 in my second row and my -3 in my third row to zeros, which I want to do. So I'm going to multiply my first row by -2, and I'm going to add it to my second row. So my first row is going to stay the same. My third row is going to stay the same. And I'm just going to change my second row. So -2 times 1 is -2, plus 2 is 0. -2 times 2 is -4, plus 2 is -2. -2 times 0 plus 3 gives me 3. -2 times 5 is -10, plus 3 is -7. And I'm going to multiply in my next step my first row by 3 and add it to my third row. So 3, well, first my first 2 rows are going to stay the same. Let me fill those in first. So 3 times 1 is 3, plus negative 3 is 0. 3 times 2 is 6, plus 1 is 7. 3 times 0 is 0, plus 2 is 2. 3 times 5 is 15, plus negative 3 gives me 12. So now, I want to get this 7 to become a 0. So if I multiply my row 2 by 7 and my row 3 by 2, it's going to take care of that for me. So if you need to write those off to the side and add them together, go ahead. Negative 7 times 0 is, or sorry, positive 7 times 0 is 0. 7 times negative 2 is negative 14. 7 times 3 is 21. 7 times negative 7 is negative 49. And then the third row, 2 times 0 is 0. 2 times 7 is 14. 2 times 2 is 4. And 2 times 12 is 24. So my first 2 rows are going to ultimately stay the same. And I'm going to add these 2 together up here to get my third row. So 0 plus 0, negative 14 plus 14, 21 plus 4, and then negative 49 plus 24. So I need, in my second row, my negative 2 to become a 1. So I'm going to multiply that second row by negative 1/2. Which is going to become 0, 1, negative 3/2, and 7/2. And then in my third row, I need that 25 to become a 1. So I'm going to multiply my third row by 1 over 25. And now I'm ready to solve. Oh, and actually I just noticed a mistake. Up here, when I was adding these 2 together, negative 49 plus 24 should have made this 25 a negative. So when I multiply that by that 1 over 25, that should give me a negative 1 there. So now I'm really ready to solve. So z is going to equal negative 1. When I go to that second row, 0x plus 1y minus 3 over 2z equals 7 over 2. So I'm going to plug in a negative 1 for z. So negative 3/2 times negative 1 is going to give me a positive 3/2. When I subtract that 3/2 from 7/2, it's going to give me 4/2, which is 2. And then I'm going to take that negative 1 and 2, and then in my first row I have a 1x plus 2y. I have 0z equals 5. So I'm going to plug 2 in for y. I don't have to worry about the negative 1. And I would subtract my 4 to get 1 for x. And then I write my ordered triple of 1, 2, negative 1. Alright, so last one. I really encourage you to pause and try this one on your own. See what you can come up with as your final answer, and then come back and compare it to mine. But as usual, the first thing you want to start with is writing your augmented matrix. So for me, I've got a 1 in my second row, and I'd rather have that in my first row. So I'm going to swap those first 2 rows. And now I want to start getting the zeros and ones that I need. So I'm going to multiply my first row, my first row by 2 and add it to my second row. So my first row is going to stay the same. My second row, 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4, plus negative 2 is 2. 2 times 2 is 4, plus negative 15 is negative 11. 2 times 18 is 36, plus 0 is 36. And then I'm going to leave my third row alone. And now I'm going to get that 3 to 0. So I'm going to multiply my first row by negative 3 and add it to my third row. So first 2 rows are going to stay the same. Negative 3 times 1 plus 3 is 0. Negative 3 times 2 is negative 6. Plus 3 is negative 3. Negative 3 times 2 is negative 6. Plus 22 is 16. Negative 3 times 18 is negative 54. Plus 2 is negative 52. So now I want to get my negative 3 to become a 0. So I'm going to multiply my second row by 3 and my third row by 2. So my first 2 rows are going to stay the same. And then if you want to jot down when you multiply what you get so that you don't lose track of that, that's fine. And then we're going to add these 2 together to become the third row. So 0 plus 0, 6 plus negative 6, negative 33 plus 32, and 108 plus negative 104. So third row, I have a negative 1, but I want a positive 1, so I'm going to multiply that row by a negative. Which is going to give me 0, 0, 1, negative 4. And in the second row, I want this 2 to be a 1, so I'm going to multiply by 1/2. And my third row stays the same. So now I'm ready to solve. So I've got that z equals negative 4. I'm going to take that negative 4 and I'm going to plug it in to my equation y minus 11 over 2z equals 18. So negative 11 over 2 times negative 4 is going to give me 22. And when I subtract 22 from 18, I get negative 4 for y. And now I'm going to plug that into my first row. So x plus 2y plus 2z equals 18. So 2 times negative 4 plus 2 times negative 4 equals 18. Negative 4 times 2 is going to give me negative 8 for both of those, which is going to give me 34 for x. And as always, an ordered triple. Alright, so that is this section. If you need to go back and watch anything, do that. Homework will be posted in the assignments. It's also on RunWeb. Let me know if you need anything.